Section 9.1, Inverse Functions and Composition. If a function f is 1 to 1, then the inverse function is the unique function for which the composition of the inverse of f of x equals inverse function of f of x equals x, and the reverse, the composition of f of the inverse function of x is equal to the f of the inverse of the function is equal to x. So let's put that into practice. We're given a function and they're asking us to show that this is in fact its inverse. To prove that, we will show the composition f of the inverse of x is equal to x, and instead of this notation we can put the equivalent f of the inverse of x, which, replacing the inverse on the inside by substitution, the inverse of the function is 2x minus 2. Evaluating the function f with this term in place of x says take 1/2 times the quantity that you're evaluating your function as, which is 2x minus 2, and then add 1 to it. So I have 1/2 times our special x plus 1. Simplifying, 1/2 times 2x leaves an x, 1/2 times -2, they're reciprocals, multiplied together gives us a -1 plus 1, minus 1 plus 1, simplifying further gives us x. So we're halfway through our proof. We've shown that in fact, yes, the composition f of its inverse is equal to an x, and the second half of the proof is the reverse order. The composition of the inverse function of f of x must equal x. To simplify on the left, we'll put an equivalence of this composition, the inverse function of f of x, and evaluate it. Starting inside the parentheses and replacing an equivalent value, f of x is 1/2 x plus 1, so it's just a substitution, and then evaluating the inverse function with this term. The inverse function tells us to double whatever is in the parentheses, so we'll take 2 times our 1/2 x plus 1 and then subtract a 2 from it. So to start off simplifying, we'll distribute 1/2 times 2x, or the other way around, I guess. 2 times 1/2 x is equal to x. 2 times 1 is 2 minus 2. Well, the 2's cancel out, leaving us with an x. So there's our proof to show that these two functions are in fact inverses of one another using composition.